going to start this video by writing out an equation from fluid dynamics, and while this equation is mathematically complicated, it's really easy to conceptually understand once you break it down. So for starters, this funny p represents density, which is the fluid dynamics equivalent of mass. This dv over dt term is a fancy way to write change in velocity over change in time, aka acceleration, and these other two terms represent forces acting on the liquid, specifically the pressure gradient, gravity, and viscosity, which is the fluid dynamics equivalent of friction. So essentially, this equation is Newton's second law for fluids, which makes it interesting because it doesn't work, despite being equivalent to a fundamental law of motion. And to understand why, we have to explore one of the most difficult questions in all of science. How does water move? Well, water flows, and to explain how flow works, we're going to use cards. The cards, which are all from the same deck and all from the same suite, are arranged from highest to lowest, with the ace of diamonds being at the bottom of the deck and the king of diamonds being at the top. Now, fluids move not as one unit, but rather flow in infinitesimally thin sheets, kind of like how these cards, when I deal them, don't move as one unit, but rather 13 separate units. When this flow is controlled because of my hand's grip, which represents viscosity, it's called laminar flow, and it's often found in high viscosity or thick fluids like honey. In fact, it's so predictable that I can pick up these cards and arrange them back in the order they were in with near-perfect accuracy. Just like the deck of cards, it's easy to predict high viscosity fluids with an equation because the flow is by nature clustered and orderly. Now, unfortunately, our oceans aren't made of maple syrup, so what about fluids like water or air? Water and air are low viscosity fluids, which can be represented in the cards by simply weakening the grip my hand has on the deck. And when that happens, it's incredibly hard for me to control even where the cards land, much less attempting to perform the far more difficult task of predicting where the cards went and ordering them. And this kind of flow has a name which you may or may not have heard of. It's called turbulence, specifically turbulent flow, but they are the same thing. It's the reason why our understanding of fluids falls apart so easily. Because in most fluids, this game is played not with 13 cards, but with trillions of particles. So what else can I tell you about this phenomenon which has stumped science for decades? Well, if you find the ratio between the forces that make a fluid move and the forces that don't make a fluid move, you can get a Reynolds number, which can give us a rough approximation of when this phenomenon happens. Sometimes funny spirals called eddies show up, and that's really it. The closeness of the unknown shows us that nature has a funny sense of humor.